All right, got another example here with some numbers and letters. Step one, let's look at and divide it up. So we're gonna put the numbers in its own room in the house, letter D by its kind and E by its kind. Anything that's a perfect square is gonna get kicked out to the fresh air, so let's look and see. So 45, it would fall right here between 36 and 49, but it's not a perfect square. So as I meander up the list, that's a fun word, isn't it, meander? What could I divide into 45? Hopefully you stopped at 9, because 9 times 5 is 45. So I can break this into a multiplication problem. Now D is an odd exponent, but there's nothing we can simplify it to or break it down into, so it just stays the square root of D. E has an even exponent, and that's going to be a perfect square, so that also stays. Now we're going to go ahead and pull out the perfect squares and leave behind the non-perfect squares. So the square root of 9 is 3, because 3 times 3 is 9. So 3. That takes care and simplifies the 9. The 5 stays in the house. We'll come back. D is not a perfect square, nor can it be simplified. The square root of e to the second is e, and that comes out of the house. So now we've taken our perfect squares out, and we're going to draw a radical and keep inside what cannot be simplified by removing any more perfect squares. We're almost finished. Don't forget, if you have a letter on the outside that has an odd exponent, it needs absolute values. So this is actually 3 times the absolute value of e times the square root of 5d. Toodles!